this video we're going to look at the Ahmed body when subjected to a transient crosswind as opposed to a steady longitudinal forward-facing wind. So we're going to begin by importing the Ahmed body file that I've downloaded from GrabCAD. You can obviously build your own if you want, or if you look at my previous tutorials, there is a tutorial that shows you how to build one. So once you've imported, we're going to check that it's importing on the XY plane. We want to add it as frozen for reasons you'll see in a bit. Yeah, it's not complex geometry, so we can ignore all that stuff. So just right click and generate and let the Ahmed body come in. What you'll notice is it's sitting with Y as the vertical. What I want to do is change that so it's Z as the vertical. I always like my XY plane to be longitudinal and lateral in their direction. So I want to do a body transformation and then a rotate. So we need to select our body, which is going to be this one there. So I want to select our axis from components. So in this case, our component will be 1 for X, excuse me, and then 0. And just checking our rotation and considering the right hand thumb rule. That should then shift to 90. And just check out the preview to make sure we're happy. Yep, struts are down, top is up. We can just right click and generate. Just checking against the scale, that's approximately the size we want. So we can begin by building our domain. I'm not that fussy that the front end's not sitting on the origin. This is for demonstration, but normally I would make sure the front face and center line are at the origin point. So begin by sketching our computational domain as we always do, a couple of heights upstream and bias downstream. Because today we're doing a crosswind case, the weight region is going to develop this way and this way. So I am biasing not just towards the back of the car, but also back and side. It seems a little too close here, so I will just make some changes with the dimensions, but we'll stay as we are. So we'll just deal with that as we move along. So what kind of width is that? 6 and 3. So maybe about that 5 and 8. Okay, so 3 meters upstream, we probably want, let's go as high as 4. Then 2 meters, probably want that to be 3. So we bring that into 2 maybe. Then we can extend that width of V1 so we can make that. Just keep playing with it till we're happy. 6 and 10, let's say. Cool, that looks right. Okay, so once we've got some sizing, we can extrude like we've done before. Let's go as high as 3 meters in the air. See how it looks. Yep. There's no real chance of getting absurd blockage from that, so we can just right click generate. Because our Ahmed body is frozen, so it's kind of not a real body, as the domain currently is, we can perform a Boolean operation. So if we go to create, then hit Boolean, then from the options here, just subtract. So target body is going to be the domain, and then tool body is going to be an Ahmed body that comes through, and you can see there it's frozen just because it's got that kind of icier look compared to that one. Right click, generate, and let's view from the top. Just cut this domain down the center, down the x-axis. So we're happy that's what we've achieved. There you go. So you can see the cutout of the Ahmed body, well, half of it anyway, and then the struts there. Just get rid of our section plane for now. What I'm going to do while we're in this software is actually name the faces just for later use. You don't necessarily have to, you can pick them, but I always find it nicer to come to later. So I'm going to name that one inlet in the X direction. The downside of this is you have to generate every single time, so it's a little bit slow. That's inlet in the Y. I'm going to group the roof and ground together because they're both going to be free slip walls. Just going to call them slip walls. Normally you'd have your ground of your domain as a no slip condition. But the trouble is we're not going to refine the mesh particularly intensely. So it's going to cause some weird boundary layer buildup, which is not really what we're going for. So that's going to be outlet Y. And that's going to be outlet X. Okay, and if I just hide a few of these, probably end up hiding them all to be fair. And then find our box select tool. There you go. Just selected our Ahmed body, change it back to single select. So what you can do if you're keen is actually break this down into different faces. So your rear kind of backlight you could have, your base you could have, you could even do the struts if you were really keen. And you could just see how the forces then vary with that. So that's not really what we're going for here. I expect this to be pretty noisy as a simulation just because the way we're approaching it. But again, just for demonstrative purposes. Cool, so once you're happy, feel free to save, shut down, and then open up the meshing software. Okay, so we're in the meshing software. We're just going to select the faces that are blocking our view of the Ahmed body. And then box select its surface. Right click, insert sizing. I'm going to put cell sizes of 1 centimeter on the surface. The reason being is it's approximately enough to get a resolved flow around it, but probably not enough to get accurate data from the simulation. I also want this to run relatively quickly. I want it to be able to run within maybe 3 or 4 hours, just so I can analyze the data and finish this tutorial off in the same day. If I view this from the bottom, you can actually see where it is and see the center line there. So that will be quite a nice thing to do to guide the cut plane we're going to apply. So the section plane always sits slightly differently, in a slightly different position between Design Modeler and meshing software. Annoys me no end, but that's just how it is. So there you go. So we've actually got some decent resolution on the struts. Well, some resolution on the struts. We've obviously got no prism layers, and we've got no weight refinement box. So just be mindful of that if you're ever going to be trusting these results. And of course, we'd probably want some prism layers on the ground, maybe not all the ground, but at least the ground local to the Ahmed body. Okay, so I'm just going to get rid of my section plane. I'm happy with that. I'm happy to save and move on to defining our boundary conditions and Gust profile. Okay, so in CFX Pre, I'm going to set up a simulation like I would if it was just a straight, continuous, steady wind simulation. And then I'll go back and kind of update the boundary conditions. So I'm going to set a total runtime of 5 seconds. Put it at 10 milliseconds per time step. We're going to leave all those constant. Don't particularly care about the turbulence model, but because it is a transient simulation, we will need to apply initial conditions for both pressure and velocity. It's got rid of one of those warnings there as well. So start by inserting the boundaries. So I'll call this one inlet X. Just leave that as 10 for now. Inlet Y. This is the one we're going to add the instantaneous or transient wind to. So this is our slip wall case. Again, just applying a free slip condition so we don't get issues with boundary layer buildup on either one. That's going to be outlet in the Y direction. Just going to set it as an outlet rather than an opening. What you'll typically see if you leave an opening and allow recirculation is you just get massive vortices generating here. Incredibly unphysical. I mean, I think you'll see something similar with this level of mesh refinement, probably towards both of the boundaries, but nothing massive to worry about. Obviously, if you are doing this to get some research quality data, I would take the time to generate an appropriate mesh. Okay, so last boundary condition. Just double check it's appropriately set as a wall. Cool, it is. Right, so we have inlets, as you can see, we have outlets. Everyone's got the appropriate boundary condition. Have a quick look into solve control to see if I've missed anything, but that all looks fine. Right. So what we do need to do is go to output control. This will determine what we save. So transient results. I can't save a lot because it's A, not going to show much, B, it's not a great PC. So if we say every 0.5 seconds we'll save a results file, seems reasonable. And we also want to monitor the forces. So if we just say full forces there, that'll give us something to interrogate at the end. We also need to add our Gust profile. So we can create an expression and call it Gust. And then we apply our definition in there. Okay, so this is here's one I made earlier kind of thing. So we've got 3 kind of group terms for our wind. So first is just a little offset. What I sometimes find is that when I do crosswind cases where one of the boundary conditions isn't doing anything, there's some numerical issue. I'm not quite sure what it is, but What I'm going to do here is just specify a really low speed wind coming in at the side, shouldn't affect the flow really, and then the kind of main gust will kick in. This one's a sine function, so it's a sine wave that has some amplitude of 5 meters per second, and then this is like a linear increasing term, so time multiplied by 2, so as time goes up, the speed of that goes up as well. So you've got a linear sinusoidal and a kind of offset term to this. You can put whatever you want in, you can develop it. I did actually put this in Google Sheets when I was tuning it, and that's the kind of profile you'll get. It's not very gusty, but it's something that you can try and error on your own. So just copy and pasting that into there. Hopefully no issues. Good. And then I'll put that into inlet Y there. When it asks for speed, I just hit the expression and just type gust. Worth saving at this point. Don't think I've missed anything, but if I have, I'll go back, correct, and then update the video appropriately. So just save and open up solution, I suppose. Okay, so I've just started in Solver Manager. I'm going to watch this for a few time steps just to ensure it's actually going on okay. If I notice any funny business, obviously I can go back and correct. Don't really want to walk away from the PC, let it run, and then come back and find a problem later on. So just a few things. In an ideal world, this RMS current number would be below 1. You're not going to see anything in the first time step, but when it comes up, you'll probably see it in the order of 10, maybe 20. What you'll also see initially at startup is this kind of warning. It basically says at the outlet, because it's experiencing some recirculation, it blocks the faces off. That will spike and then drop back down, hopefully. If it persists, worth just making the domain slightly larger, but yeah. You'll see something, maybe it's a 20%, and then it should just die away. Okay, just keep watching this for a minute. Hopefully that number will settle. When I've run this kind of case before, it has done. So one thing we want to do is create a new monitor. And we can plot the force in the, well, we can plot it in the X and the Y direction. We're just looking at pressure force here because we don't expect anything from our shear forces really. We haven't resolved that properly on the surface of the car using like a prism layer. Okay, that outlet condition is now spiked to nearly 30%. It's very early on, so I'm not too worried. We're about 0.1 of a second now. Yeah. I'll leave it to do what it wants. We'll get there eventually. In this end of this next time step, though, we should get our initial force, which should be overly large. It should settle and then it'll spike with the increasing wind speeds. Okay, so we have some kind of force. RMS current number is currently this, but as you saw, the wind profile will end up spiking, so we're currently very early on. So I'm not getting too excited just there. But yeah, this seems to be dying away. All right, so I'll stop the video here and I'll pick it up when it's finished. Okay, so it looks like this simulation finished and potentially successfully, so we'll just check the results. Alright, so there's my Ahmed body. Just going to hide the wireframe, show the Ahmed body, and probably put some think I'll actually just use an isosurface of pressure around. I'm not going to bother using things like CP. Just think it gets a bit confused when you've got different velocities coming into the domain. Because normally you normalise it by the inlet velocity, but obviously ours constantly changes. And then is that the velocity at the particular time, because it takes time to convect downstream. It's all a bit messy, so I'm just going to leave it like this for the moment. We do have animations. I mean, it's not really an animation, it's one every, I think, half a second. So I'll just skip through the individual time steps. So time step 1 is half a second. Okay, that must be one of the parts where the airspeed died down a bit. Yeah, got this kind of classic leading edge separation vortex that you get from side winds and then kind of around the leeward face. That's kind of exhibited a bit in the struts as well. I suppose we could look a little bit deeper. We could go, for example, say plane. Just cut the Z. Maybe 0.3 meters. I can't remember how tall the Ahmed body is in its original form. Okay, not that tall. Try that. Bring it down a little bit. A little bit more. Cool. So just chuck some streamlines on. If we say we're going to need quite a few because it's obviously quite a big surface. There you go. Whoops. Try that again. Okie doke. So just zooming out a little bit. Okay, see a little negative pressure core has reached there. Like I said, I'm kind of expecting some level of instability from this boundary condition setup because we've left a really coarse mesh. We haven't really left much space for the weight to dissipate. So just flicking back through my animation. It's going to take a bit longer to load now, obviously, with 2,500 streamlines, but yeah, you can see the weight kind of shifting around with different intensities of crosswind. So yeah. Yeah, so that looks like the lowest speed. Looks like one of those troughs, let's call it, in the lateral velocity. That's definitely the deepest one. Okay. All the streamlines are pretty much heading in that direction with some, I think that's that kind of low value we put in just to keep the flow moving. Okay, cool. That's obviously what it is. I hope that was helpful. I will also make one of these in Fluent as well to help people who prefer to use Fluent over CFX. But if you have any questions, obviously feel free to drop them into the comment section. Thanks for watching.